When it comes to use R for your data, you could type all these things in and do your pretty plots, and you can work out means and do all sorts of statistical stuff and things. But it's a real shame if then when you can log off R, that's kind of gone forever, okay? So this is probably one of the fundamental things of R. If you're doing stuff for your proper work, it's good practice to keep a script file, kind of almost like a lab book. You keep lab books, don't you? Because you're proper scientists, yeah. Okay. And so the R equivalent of a lab book is a script. So we go up here and click R script, and that starts the thing here. And normally your first kind of lines of action would be importing some data, but I'm just going to sort of get some data from a built-in data set because I'm lazy. I mean, there's an import thing over here which will import sort of data you'd save from a spreadsheet and stuff and things. But and there's a whole web document on importing data into R. But we'll just get some data in that way. Okay, yeah. And nothing happens. I mean, I press return there. Nothing happens. Okay, yeah. If I want to run that line, I can put the cursor next to it and click run, and then it happens down here. Okay. So if we clear our data space, put the cursor there and click run, and then that line runs. Okay. And then I could do a line which said basically head of, it's OR is my data, isn't it? And then I might want to do dim, which tells me the dimensions of a data frame. Nothing's happened, but then when I'm next to it, I click run and I get the head of it, the thing moves down, I run the next line. So I can step through a whole bunch of instructions. That's really, really useful because if I write that set of instructions to work, so say this was my dental equine data or sort of GWAS data or whatever you've got, okay, yeah. I write a set of instructions here which kind of does things to that data, summarizes the data, does some pictures of the data, some statistics of that data. And say I'm halfway through my project, I've got all that nice and good and it generates all the right output and things and stuff. And then a few weeks later I've got some more data. I don't need to write any of this kind of guff again. I need to import the latest data set, one line changes, and then everything will happen again. So I've not wasted any effort, and it's very reproducible. If things don't work out, I can see why not, yeah? So we did, we could do a histogram of the age data, I guess, there. And we could do that sort of, what's that? If we go back to the history tab here, I can find that one that did that. I didn't save it, did I? Damn. Right, let's just, what was it? Q plot. And it was age, circumference, color equals tree, I think, yeah. Data equals OR. Now if I try and run that, I'll get a painful error probably, okay. That's because I need to load that special library in, and if I'm doing a script file, I can write some words to do that rather than clicking. So I can do this bit here. So let's just run the whole lot. Loads in a library, loads in the data, tells me a bit about the data, and then does a plot. And I can add my lines here. And we can spread, stuff will spread over several lines to make it easier, so let's just run those two bits. Okay. Right, so that thing there is called a script file. You can save that, so there's a save button, and that then becomes a sort of a recipe. So sort of, for like a sort of a PhD or research project, you might have a bunch of script files which take data in, do things to data, plot the data, analyze sort of statistics. You can even make them write out sort of graphics files. So rather than using the clicky bits here, you can have them save things to sort of specific folders. I mean, say you were doing a massive analysis of a data set which has 100 columns wide. You could write a script which would generate 100 histograms. It would just go across it, and then write them all out with a different name into a folder on your hard disk. So that would all happen sort of magically. So you will be done by 4 o'clock, whereas your friends that use Excel will still be working at midnight, which is the sort of the magic of it all. These script files, good practice of this as well is to sort of give some clues, because my memory is not fabulous. So you can write things like Ian's demo script file. So anything you start with one of these hash things appears in green and doesn't do stuff. So I could write something here like plot a line graph. Okay. So those bits, if I run them, nothing happens. Nothing changes, but they're a record for me of what my file's doing, and if there's a bit that's broken, I might put a little comment saying, this bit doesn't work, it's time for bed, have a look at it tomorrow, okay. But it's very good to very early on in R start using script files. Even when you learn R, maybe because the way I would learn R, probably the third useful thing I'll say today, is there's a bunch of PDFs on the web, like beginners R tutorial, R for beginners. None of them is perfect, but they're all okay. Get one of those and start working through the first few pages of that until you feel you're ready to go alone. And what you'll do there is they'll have you do things like they'll have you type some numbers in, they'll have you add some numbers together, they'll have you draw some simple pictures. You might choose to kind of, as you type things and tweak things a bit, put them in a script file like this so you can run them again. And it's when we've done the Bioscience MSc, where we used to teach R here, a lot of the students would kind of create a big script file, sort of as we all typed along together, putting comments saying, this draws quite a neat graph, and then have the code there so that they could then look back up and see how they're drawing a graph. It's like a lab book. It records kind of what you've done. Finally, I'll show you doing some statistics. You're aware of this thing called statistics, yeah, where we sort of calculate things about data and make decisions and stuff. So you can in R R is the sort of god or goddess of stats, but we might want to fit straight lines. We might want to fit like a straight line model through these trees. So there's a function there called linear model, and there we basically say model the circumference with the age in this data. And if we run that bit of statistics there, we should get we get the slope and the intercept of a straight line, and we can store that somewhere. So if we do that, that stores a statistical model in a thing called mod, which has all sorts of things about the statistical model, and then we can find out more about it by using a doing word, a function called summary. And if we run that, then we get a sort of this is the sort of output you get. So when you do a sort of a linear model, straight line model, and it tells you sort of, it's got sort of p-values and sort of stars for significance and stuff and things. So sort of, there's just an absolute mass of stuff in R which will do basic statistical tests, like sort of t-tests and things, fit straight lines, kind of curvy lines, do sort of time-varying models. Generally, when new methodology comes out, R's the commonest place for it to appear, and someone will come up with a new way of analysing GWAS data or sort of horse heads or something, and they will write a package, and you load that into R, and then you've now got access to their sort of genius. They'll write a peer-reviewed paper and say this new method is available in an R package, blah blah blah. You download that, and then you can analyse the data the same way as they have done. But sort of that's a bit like this doing word took some things, some instructions, and did a plot. This doing word takes some data and you tell it the relationship you're interested in, and it fits a linear model, and then that sort of doing word here, this function, summarises that model.